Hi everybody. In this video we will do our homework for section 6.3, finding the probability using a normal distribution. And as you can see, I have my homework screen set up. Here's Hawks, here's my calculator, and here's my doodle sheet called OneNote. So let's go into Certify and see what we have to do. We actually have 6 problems and we have 2 lives, so we can get 4 out of the 6 correct to certify. Although I would recommend that you do all 6 because, once again, the ones you skip will likely be the ones on the test. And as usual, I am going to do my work in practice because in case I make a mistake, I might want to look at the feedback. Okay, here is our first problem. The weights of newborn baby boars are believed to have a normal distribution with a mean weight of 3252 and a standard deviation of 614 grams. If a newborn baby boy born at the hospital is randomly selected, find the probability that he will weigh less than 3,804 pounds. So we want to find the probability that the random variable x is strictly less than 3,804. Which ironically, since this is a continuous distribution, that will be equal to the probability that x is less than or equal to 3,804. And in this case, we have that x is a normal distribution with a mean of 3252 and a standard deviation of 614. And we are going to use our calculator to do this particular one. So we are going to go into normal CDF. You can do that by clicking second, VARS, go down to number 2. We want to, our lower limit is going to be as low as the calculator can get, which was -1 times 10 to the 99th. The upper value is going to be 3,804. The mean is 3252. And the variance is 614. Hit enter again, and again. And here's what we have. We have 0.81567. So the probability of x being strictly less than 3,804 is equal to 0.81567, which should round to 0.8157. And we did it correctly. Okay, here is our next problem. Suppose the mean income of firms in the industry for a year is $50 million with the standard deviation is $17 million. If the incomes are distributed normally, what is the probability that their randomly selected firm will earn less than $87 million? Now for this one, we are going to use tables. Okay, so here, x is a normally distributed random variable with a mean of 50 and a variance of 17. No, I'm sorry, a standard deviation of 17. Okay, we're looking for the value. We want to find the probability that x is less than or equal to 87, which is equal to the probability that x is less than or equal to 87. Okay, first thing you want to do is you want to compute the z-score. The z-score is going to be the x value, 87, minus 50, divided by 17. That will be equal to 37 over 17. 37 divided by 17 is going to give me 0.217. No, 2.176, which should round to 2.18. Okay, so this is going to be equal to the probability that z is less than 2.18. Using a table lookup, we can come to we want to use this table here, negative infinity to z, because we have a positive value. Click on that, find 2.1. There's 2.1, 2.19, 2.18. Click on that. Loads into there, submit your answer, and there you go, you're correct. Okay, and this brings us to problem number 3. A soft drink machine, so I think we've seen this before, outputs a mean of 27 ounces per cup. The machine's output is normally distributed with a standard deviation of 2. So we are dealing with a random variable, x, with a mean of 27 ounces and a standard deviation of 2 ounces. And we have here, what is the probability of overfilling a 29-ounce cup? That is the probability that x is greater than 29, which is the same as the probability that x is greater than or equal to 29. Now we're going to use our calculator for this one. So let's go into second distribution, normal CDF as before. Okay, now this time our lower limit happens to be 29. Our upper limit happens to be the largest value the calculator can take, which is going to be 1 second, comma, 99. Our mean is 27. Standard deviation is 2. And that gives us an answer of 0.15865. That's my 5th decimal place. So this should round to 0.1587. And there you go. Okay, moving on. Here we have the life of light bulbs is distributed normally. The variance of the lifetime is 225, and the mean lifetime of the bulb is 580 hours. Find the probability of a bulb lasting for at least 605 hours. So at least implies that we are looking for the probability that x is greater than or equal to 605. Okay, and we have here that x is a normal random variable with a mean of 580 hours. But what is the standard deviation? This value of 225 is not the standard deviation. That is the variance, denoted by sigma squared. So sigma squared is equal to 225. The question here is, what is sigma? Well, it's going to be equal to the square root of 225. We can use our calculator to figure that out. Second, square root 225. 15. So our standard deviation happens to be 15. So this is a normally distributed random variable with a mean of 580 and a variance of 15. Standard deviation of 15, my apologies. So with that information, we can go ahead and use our table because we used our calculator last time, didn't we? Yeah, so we're going to go ahead and use tables. Okay, the first thing that we need to do is figure out what the z-score is. Okay, so the z-score is going to be equal to our x value, which is 605, minus 580, divided by the standard deviation, which is 15. Okay, using our calculator, let's go ahead and do the numerator first. 605 minus 580, that's my answer. Divide that by 15, and we get 1.66667. However, our tables only go to the 100th place, so we can write this as 1.67. Okay, so it turns out that the probability of x being greater than or equal to 605 is going to be equal to the probability that z is less than or equal to negative 1.67. So let's go ahead and look that up. That is going to be this table here. Okay. Negative 1.6 is right down here. 0.69, negative 1.68, negative 1.67. Click on that. Should load it right there. Submit your answer, and we have it correct. And if you've gotten this far, you have mastered the homework, and you can complete it, and you can move on or submit it and say it's done. But if you do, you will lose out on practicing on the last class of problems. And these are these problems right here. So here we have question 5, or problem 5. The weights of steers in the herd are distributed normally. The variance, there's that variance again, is 10,000. So sigma squared is equal to 10,000. And the mean square rate, mu, is going to be 1,400. Okay, what is the probability that a randomly selected steer is going to be greater than 1539 or less than or equal to 1580? Before we do this, we need to figure out what the standard deviation is. If the variance is 10,000, then the standard deviation is going to be the square root of 10,000. Which is the square root of 10 to the 4th, which is 10 squared, or 100. And that means that we have a normal distribution with a mean of 1400 and a variance of 100. And we can figure this out using our calculator. So, not that. Let's get out of there. We want to go into a distribution, normal CDF. What's our lower limit? 1539. What's our upper limit? 1580. What is our mean? 1400. What is our standard deviation? 100. And that gives us an answer of 0.0463. My fifth decimal place is a 3, so I don't need to round up. And let's see if that actually happens to be correct. 0.0463. And it is wrong. Why is it wrong? Because I transposed the 6 and the 4. So let's try that one more time. Much better. There we go. And that brings us to our very last problem, which we are going to do using tables. And this will give you yet another appreciation for the calculator. Trucks in a delivery fleet travel with a mean of 120 miles and a standard deviation of 10 miles per every single day. Okay, so that means we're dealing with a random variable. As usual, we're going to call it x, which is a normally distributed random variable with a mean of 120 and a standard deviation of 10. The mileage is distributed normally, and we want to find the probability that x is greater than or equal to 133 and less than or equal to 138. And we want to do this using z-scores. Okay, so let's call z1 133 minus the mean, which is 120, divided by the standard deviation, which is 10. Okay, that will give us 133 minus 120, 13 divided by 10, 1.3. So z1 is 1.3. z2 is equal to 138 minus 120 divided by 10. 138 minus 120 divided by 10. 10, there we go, 1.8. So this is equal to 1.8. So the probability that x is between 133 and 138 is equal to the probability of z being between 1.3 and 1.8, which will be equal to the probability of z being less than or equal to 1.8 minus the probability of z being less than or equal to 1.3. Okay, so using our table of lookups, we can start over here. And we need to look up 1.8. 1.80 is right there. That is 0.09, no, I'm sorry, yeah, 0.9641. 0.9641. 1.3 is right there at 0.9032 minus 0.9032. Okay, come back and get back to our calculator. 0.9641 minus 0.9032. And that gives me 0.0609. Well, let's see if that's right. 0.0609. And there you go. And that completes your homework. Once again, if you have any questions, please feel free to contact me. Stay tuned as we move on to section 6.4, where I give you value for probability. And you have to find, and a scenario, and then you have to go find this as well. And until then, this is Bob Boyle, signing off.